Thanks everyone. Welcome to Oddschecker HQ. Hopefully you've had time to grab a beer and some pizza. As Matt said, today I'm going to talk around migrating to Oddschecker's journey to migrate to Google Cloud Platform. So today I'm going to cover sort of who's Oddschecker, what we do here, and how we're growing as a company. I'm going to cover why we chose the cloud and why we chose Google as our cloud platform provider, and then also some key learnings and some next steps that we're going to take as a company. So a bit of background about myself. I'm head of tech here at Oddschecker, so I cover infrastructure, testing, and development. I did start off as a software engineer, but now I've gone to management. I don't get to touch code anymore, so I'll leave that to developers. So a brief bit about Oddschecker. So we started in 1999. We are currently owned by CVC as part of the Sky Betting Gaming Group. We are a odds comparison website, so like Money Supermarket and Go Compare, we will show you the best odds for all the different bookmakers for a given sporting event. So Manchester United versus Chelsea, for example. We will show you the odds from all the different bookmakers, as you can see at the bottom of the slide there. We also offer tips and insight, so helping the punters placing bets. And we also offer integrated betting, and that allows you to place bets through your bookmakers without having to leave our site. So it's a new addition in the last couple of years, but it really helps people stay within our product, and it's a great feature for the customers. That's sort of our UK site. In the last year we launched a new international platform, and that was across 5 new territories. So that's launched in Australia, Italy, Germany, Denmark, and Spain. That was a new platform that we wrote from the ground up using React, and just covering Oddschecker in a couple of sort of interesting numbers. We integrated with 100 different bookmakers from around the world. So that's covering bookmakers from Australia, all throughout Europe. So it's quite a lot of data coming into our platform all at one time. And on a peak time, which is normally a Saturday, we're handling around 5,000 updates a second across 30 million different odds, and that's sort of a unit of an odd, those squares there. So it's a fair amount of data points we're processing at one time. So, is that better now? So why the cloud? So as I mentioned, Oddschecker is growing. So we sort of grew the international business to create this new platform, but we also decided to grow to help to enhance publishers' websites. So Oddschecker Connect is our new proposition that we're doing, and that's integrated widgets. And this was our first cloud-first project. This is creating fully responsive widgets that enhance customers' content through odds comparison. We had, for example, if someone wrote a content article about Chelsea to win the league, the outcome of Oddschecker Connect would be to put a widget on that publisher's website, which would then service odds about Chelsea to win the league. The initial outcome of this project was to go live on the Daily Mail, so it's quite a big test for a first launch of a product. That's the initial designs and platforms. So the top one there is around an offer, so that's signing someone up to a customer website, and the second one there is sort of the odds comparison aspect, so the best price for all the different bookmakers. In this case, it was only Paddy Power on the Daily Mail, and that's what it looked like in the context of the Daily Mail website. So that's Oddschecker Connect. We launched on the platform during Cheltenham, which was the biggest betting event of the calendar, so it's quite a high traffic event for us, and it was a success from our perspective. The platform launched seamlessly on Google Cloud Platform, and we didn't suffer any outages due to traffic, which was a good start. So why did we need to go to the cloud in the first place? So we had problems with sort of scalability. So we're in a physical data center at the moment, and obviously this new platform to handle the traffic that we had to do, we needed a new platform to host that traffic on. So moving to the cloud seemed a sensible option, providing us an unlimited scalable platform. And also, as you can imagine, the sporting calendar, it's quite spiky traffic. So actually being able to scale using auto-scaling up and down is quite a good cost-saving exercise for us, so we don't have any redundant hardware for our platform. Obviously, operational overhead, so managing hardware failures in data center, that's obviously something that with cloud platforms now, we don't need to worry about. So trying to get that off our sort of management aspect is something we try to do. And also in experimentation. So developers being able to use the platform to do proof of concepts, growing up a little bit from doing it on a laptop to actually doing it on a physical environment. So giving you the ability without relying on too much infrastructure to be able to create a test bed, test a proof of concept, and then test it hopefully all the way to production. And all of this comes together to hopefully decrease time to market. So when we're building products, actually getting it to market as fast as we can is sort of the aim of why we want to move to the cloud. So why do we actually choose Google's cloud? One of the sort of primary reasons was for Kubernetes, as Google were the people that built it initially. So it sort of made sense. We did evaluate other cloud providers, however, they container providers, but Kubernetes being the market leader at the time, sort of the best solution for us, and it met all our requirements. Obviously, Google Container Engine specifically, Google manage it, so it takes all the overhead out of managing it and create a container cluster very, very quickly. Google's private network, so is this microphone actually
it's a bit
in and out? Can you hear me without it?
I think give up and just shout.
I'll shout.
It's working now.
Okay, if you can't hear me, put your hand up and I'll try and shout louder. So yeah, Google's private network, obviously building on the backbone of Google is going to be a great network to use. It's global reach for our international business, something that we obviously building on the back of that with getting prices from around the world into our platform is what we're going to try and use it for. By the minute billing is quite a standout feature that we wanted to use. So for this sort of experimentation and proof of concepts, as well as the scalability aspect, sort of quite a standout feature over other cloud providers. And some of the compute engine features, such as custom VM sizes, our hardware in our data center is quite bespoke. So being able to actually choose the sizes of VMs, so we don't have to worry about having VMs that you're not utilizing all of its capacity. And also the suggested cost saving feature is really good. So if we're running a VM that you're not using a lot of the capacity, Google will suggest you should power that, reduce the size of that VM, and you'll get the cost saving aspect as well. So that keeps our finance department happy. So that's sort of why we chose the cloud and why we chose Google's cloud specifically. So how do we actually go and build Oddschecker Connect? So before we started the project, we set ourselves some goals. So the platform should be easy to integrate, it should be fully responsive, and it should be contextual, so serving relevant bets to content articles. How do we actually go around solving those goals? So in order to integrate the widget, it's just one JS tag and a div tag where you want the content article. There's a couple of metadata tags within the div, but that's as simple as it is. So people don't have to build any complicated CMSs to manage the Connect platform. We built it using React and Node. We sort of benchmarked and tested this within containers, and it's sort of the most sensible option for sort of scaling. That's sort of a brief overview of the architecture. So we split up the component into a main sort of server and then an analyzer. These are both horizontally scalable using Kubernetes autoscalers, and they're built. They use CPU, so as and when the CPU spikes on containers, they'll scale up and down as required. Just to run through how the actual contextual algorithm works, when you load the widget, it will parse all the text from a page. It it will then send that down to the server. That will then do some natural language processing, picking out all the keywords from the article. That will then be passed to our data platform, which is backed by our Elasticsearch data warehouse, and that will then serve you relevant data back to the website. That whole round trip is about 500 milliseconds to a second. However, once the caching kicks in, it drops down to 100, 200 milliseconds. We also utilize Google buckets with the HTTP2 capability to ensure that we can improve the performance of loading static assets on the sites. So as obviously part of doing this, it was new to us when we for containers. So as part of the project, we actually worked quite closely with JetStack, who helped us come in, did sort of a good readiness check to make sure we were comfortable that we could handle the Daily Mail's traffic and load they're going to put on the platform. They also helped us with training, obviously, the rest of our development team so we can keep doing this platform going forward. So how do we release this platform? Starting in a new environment actually gave us an opportunity where we could actually think about how we release code at Oddschecker. So that actually we took a step back and thought, what were some of the problems we have when we were releasing code at Oddschecker? And we sort of came up with a few requirements around making sure developers could be in charge of the release process a lot more, ensuring that we can do QA to the right level we require, and obviously rapid delivery, which is what we all want. So we decided to do sort of feature branch-based development, and we did it using GitLab. So GitLab, being Kubernetes native out the box, is quite a good fit for us. It has a lot of the built-in features of Jenkins that you require plugins for built into the platform, which is really beneficial for us. The way we've got it configured on Kubernetes is, as and when you push a feature branch, you will get a URL created for that environment, which means that the QA can test that specific feature in isolation. And then when that feature's merged in, that branch will get cleaned up. Obviously, the GitLab CI file that comes as part of the package gives the developers the control to work out exactly how they want to release the project. So you can configure all the behavior you need to release the platform within one file. So I'm just going to detail through that file very briefly. So that's an extract from one of the files, and I'm just going to touch on a few elements of that file. So as I said before, you pass through the variable name here, and then that will create the URL for the QA environment and for people to test on, specifically for a feature branch. So you can specify where you want to run it, and which zones and which clusters you need to deploy it to. And within this, the script tag is how you sort of display, or how we push it onto the Kubernetes cluster. So we've got a separate review namespace, which is used to host all our review branches. And the service and deployment and ingress obviously describe how the cluster is going to run. Specifically within the deployment YAML file, we can put all our readiness checks and health checks, so when the container is ready to serve traffic, and obviously the ingress and service to describe how traffic gets to those containers. You also can define the update strategy, so how you're going to upgrade the containers that are currently running, so how many replicas to create. It's all configured in one file. So it gives a lot of the developers full control over the release process, and it's payback dividends for us here because the developers have actually managed to create new environments for new projects without any involvement for our operations team. So that nearly all the way to production. So it's a very good setup we've now got. And it's a lot better than what we have on-prem. So what have we sort of learned on the way? So a quick question is sort of, what happens to all your operational problems when you migrate to the cloud? And the answer is nothing. They all just move to the cloud. So lifting and shifting doesn't really work. So we've taken the opportunity now to actually reevaluate everything we're doing to make sure that it's running cloud native and at the right level, to make sure that we're utilizing the platform as we should be. So a couple of other things we sort of learned along the way. Configuration as code. So making sure that everything you do on the cloud is in some form of configuration file. We chose to use Terraform and Ansible. Terraform's got quite good support for Google Cloud Platform now. It's sort of last couple of months it's really sort of ramped up. Where there are gaps, we're using Ansible to carry on the configuration. Cluster resiliency. So while the cloud is this amazing new thing, or not new anymore, but it's still not as resilient as, so stuff can still go wrong. So ensuring that you're running across region and definitely across node is something that we need to ensure we're doing. It's caught us short a couple of times. Luckily not in production, but that's sort of just a sort of gotcha to make you aware. Specifically with regards to Google, when you use stuff in alpha and beta, they can change it without informing you. So we've had a couple of problems after production where they've changed an API endpoint and it's broken our cluster configuration, which has caused us to come down in our sort of development environments. And sometimes the documentation, as always, keeping that up to date is difficult at the best of times. So if there are any, you read documentation, it's outdated, then obviously look on Slack channels or any other means. So that's sort of where we are with cloud and sort of what we learned along the way. What we're going to do in the future is we're looking to keep expanding Oddschecker Connect. So building additional widget variants. So keep expanding that product suite and hopefully building a self-managed CMS so we can give it to consumers to build platforms and products a lot faster. And continue with our cloud migration. So we've got our websites, APIs and backend systems that are still to migrate. APIs should be done very soon. And we're taking our time, as I said before, not to lift and shift, so actually utilize the Kubernetes, making it a fully scalable platform. And so we can utilize the cloud native capabilities as much as we can. That's everything.